Nutrition Science, Introduction to Carbohydrates. Carbohydrates are found not just in grains or in sweets or processed foods, but in every food group. In fact, carbohydrates are the most abundant nutrient, except water, in the diets of most humans. Since the dawn of agriculture, human cultures have relied on staple grains such as corn, rice, and wheat as the foundation of their diets, and these products are rich in carbohydrates. But fruits and vegetables, dairy products, legumes, and nuts also have naturally occurring carbohydrates. And of course, carbohydrates are a key ingredient in desserts, sugar-sweetened beverages like sodas, and many of the packaged snack foods that are readily available. And let's face it, it can be hard to stop eating. In other words, if someone says they eat a high carbohydrate diet, that could mean many different things. They very well could be talking about a balanced diet focused on whole foods. The diet industry likes to sell us single messages about good and bad foods. And these days we tend to hear that carbohydrates are in the bad group. But given that carbohydrates are in so many different types of food, that's obviously an oversimplified message. And it's not fair to all of the awesome sources of carbohydrates in the world of food. Not all carbohydrate-rich foods are the same. In this unit, you'll learn to appreciate the nutrient-dense carbohydrate foods, identify which don't offer as valuable a nutritional package, and understand how a balanced diet can include all of them. Nutrition science and everyday application, the types of carbohydrates. Get acquainted with the chemical structure of different types of carbohydrates and learn where we find them in foods. First, all carbohydrates are made of the same chemical elements, carbon. That's the carbo part. Hydrogen and oxygen in about a 2-to-1 proportion, just like in H2O. That's the hydrate part. For this reason, you may see carbohydrates abbreviated as CHO. Carbohydrates can be divided into two main types, simple and complex. Simple carbohydrates are made up of just one or two sugar units, whereas complex carbohydrates are made up of many sugar units. We'll look at each of these in turn. Simple carbohydrates. Simple carbohydrates are sometimes called sugars or simple sugars. There are two types of simple carbohydrates, monosaccharides and disaccharides. Monosaccharides contain just one sugar unit, so they're the smallest of the carbohydrates. The prefix mono means one. The small size of monosaccharides gives them a special role in digestion and metabolism. Food carbohydrates have to be broken down in monosaccharides before they can be absorbed in the gastrointestinal tract, and they also circulate in blood in monosaccharide form. There are 3 monosaccharides: 1 glucose, 2 fructose, 3 galactose. Note that all 3 have the same chemical formula. C6H12O6. The atoms are just arranged a bit differently. Glucose is the main product of photosynthesis. Plants make glucose as a way of storing the sun's energy in a form that can be used for growth and reproduction. In humans, glucose is one of the most important nutrients for fueling the body. It's especially important for the brain and nervous system, which aren't very good at using other fuel sources. Muscles, on the other hand, can use fat as an energy source. In practice, your muscles are usually using some combination of fat and glucose for energy. Food sources of glucose. Glucose is found in fruits and vegetables, as well as honey, corn syrup, and high fructose corn syrup. All plants make glucose, but much of the glucose is used to make starch, fiber, and other nutrients. Fructose is special because it is the sweetest carbohydrates. Plants make a lot of fructose as a way of attracting insects and animals, which help plants reproduce. For example, plants make nectar, which is high in fructose and very sweet, to attract insects that will pollinate it. Plants also put fructose into fruit to make it tastier. Animals eat the fruit, wander away, and later poop out the seeds from the fruit, thereby sowing the seeds of the next generation. Animal gets a meal, and the plants get to reproduce. Win-win. A bee collects sweet nectar from a flower, in the process spreading pollen from flower to flower and helping plants to reproduce. Bees use nectar to make honey, which humans harvest for use as a sweetener. Honey contains a mix of sucrose, fructose, and glucose. A kiwi is sweetened in part by fructose. Animals enjoy the sweet fruit and then later poop out the seeds, sowing them for a new generation of kiwi trees. Food sources of galactose. Galactose is found in milk and dairy products made from milk. But it's almost always linked to glucose to form a disaccharide. We rarely find it in our food supply in monosaccharide form. The second type of simple carbohydrates is disaccharides. They contain two sugar units bonded together. There are 3 disaccharides: maltose, which is glucose plus glucose; sucrose, which is glucose plus fructose; and lactose, which is glucose plus galactose. Maltose is made of 2 glucose molecules bonded together. It doesn't occur naturally in any appreciable amount in foods, with one exception: sprouted grains. Grains contain a lot of starch, which is made of long chains of glucose. And when the seed of grain starts to sprout, it begins to break down that starch, creating maltose. If bread is made from those sprouted grains, that bread will have some maltose. Sprouted grain bread is usually a little heavier and sweeter than bread made from regular flour. Maltose also plays a role in the production of beer and liquor, because this process involves the fermentation of grains or other carbohydrate sources. Maltose is formed during the breakdown of those carbohydrates, but there is very little remaining once the fermentation process is complete. You can taste the sweetness of maltose if you hold a starchy food in your mouth for a minute or so. Try this with a simple food like a soda cracker. Starch is not sweet, but as the starch in the cracker begins to break down with the action of salivary amylase, maltose will form and you'll taste the sweetness. Sucrose is made of a glucose molecule bonded to a fructose molecule. It's made by plants for the same reason as fructose, to attract animals to eat it and thereby spreading the seeds. Sucrose is naturally occurring in fruits and vegetables. Most fruits and vegetables contain a mixture of glucose, fructose, and sucrose. But humans also have figured out how to concentrate the sucrose in plants, usually sugar cane or sugar beets, to make refined table sugar. We also find sucrose in maple sugar and honey. The sucrose found in a sweet potato is chemically identical to the sucrose found in table sugar. Likewise, the fructose found in a fig is chemically identical to the fructose found in high fructose corn syrup. As we'll discuss more later, what's different is the package the sugars come in. When you eat a sweet potato or a fig, you also get lots of fiber, vitamins, and minerals in that package, whereas sugar and high fructose corn syrup only provide sugar, nothing else. It's not a bad thing to eat sugar, but after all, it's a vital fuel for our brain and nervous system. But paying attention to the packaging it comes in can help us make good overall choices for health.